Hi, everyone. Welcome back to Context Talks. Today, I have with me Stephane Fellah. Hey, Stephane, how are you?
Hi, Vivek. Nice to meet you. And thank you for inviting me to your podcast to discuss
Yeah,
a
I'm.
very
Yeah, I'm
fascinating
glad
topic.
we've. Yeah, I mean, I'm glad we're finally able to do this. Right? So
Right.
it took us a while to get this to get the timing of this episode right. But yeah, I'm excited about this conversation, Stephane, today. Right now, for the audience, Stephane is the founder of Geoknoesis, a semantic AI and knowledge graph consultancy. He has spent 12 years as chief knowledge scientist at Image Matters, has run projects for DARPA, NGA, SOCOM, and other defense and intelligence agencies. But more importantly, he's the lead editor of the HSML specification under the IEEE Spatial Web standard and principal author at DCAS US. He probably is one of those few people alive who can actually trace a direct line from the earliest days of semantic web to the current LLM powered knowledge graph resurgence. Right? Stefan, excited to have you here.
Well, thank you so much.
Right. Now, Stefan, let's get into this. I know you encountered RDF in the previous millennia, right?
That's right.
1999, 27 years back.
Yes.
And you've been working in this field for a considerable time now, right? And obviously, semantic web is way more cool now. Everybody wants to build a semantic layer, context layer, and so on and so forth, right? What do you think remains still a misunderstood concept about semantic web? What do you think is something people still have not been able to, fully, you know, fully, understand truly, right? And would end up committing mistakes.
Well, it has been a long journey to kind of evangelize semantic web. As you say, I started in 1999, and my first exposure to RDF was to Open Geospatial Consortium. I was involved in defining geospatial standards to enable interoperability. At the time, 1999, people started to talk about web services and interoperability for API and XML. So XML was a big thing, and that's why I came across a standard called GML, Geographic Markup Language, and the version 1.0 was in RDF. So that was the first time I came across this standard. And for me, it was, I was working in production of photogrammetry, imagery, and GIS, and you were dealing with always with different formats. So you have like every software have different ways to communicate. You have to do conversion or all kind of thing. And the idea of having a interoperable format was very appealing. And a lot of people were working on this thing, and everyone was on the bandwagon of XML. And they thought that, well, XML resolve all the problem, like HTML, solve all problem of durability for sharing document. They thought that XML will solve a problem. But there was this guy from a Galdos Canadian company that proposed his geographic markup language, and it was an RDF 1.0. And I started looking at that, and I discovered what ontology was about. I heard about ontology a little when I was studying, 5-6 years ago in engineering school. But I was very intrigued, and that's where I had this light bulb that people are missing, that interoperability is not about syntax and structure. It's also about sharing meaning.
Mm-hmm.
That was the most difficult thing to make understand people, because most of the people in the industry until today, I'm still saying that today, mostly they are coming from a relational database, they're sifting in table and columns and schema. It was XML or it's JSON, and everyone thought we can solve all interoperability problem by just defining a new API. So what happened, GML at the time, the version 1.0 was in RDF, but then because of pressure market, the big players like Microsoft and Oracle, they were pushing XML so hard that people say, okay, this must be the right way. So what happened is they moved from RDF to XML and XML schema.
Okay.
And at the time, I saw that was a big mistake, because by creating new schema, you create just new silos of standards, and interoperability was never achieved. Before we achieve it, was very easy to produce new schema. It was very easy to exchange data in XML. But on the consuming side, the machine receives that, they cannot make sense of the information because they are missing the meaning. So I spent my years of my career trying to explain what's XML, what's RDF, and what's that is not XML. And RDF XML was not really helping at the time because people found it very hard to parse. I said, "Oh, this is too hard. This XML." They thought it was the same thing. So they missed that RDF was kind of data model. You know, it's a triple model, and it has multiple serialization. You can serialize at TTL in JSON now, and triple, quad, etc. And so for a period of 10 years, there was I was preaching in the desert for quite a while. I was a chair of geosemantic, and I feel really lonely. It was a big organization, like 400 people. There were only like maybe 5 or 6 people that really understood the significance of RDF. And the other thing is like the standards were not ready also, like the ontology language. It was Dama plus Soul at the time. RDF schema kind of get starting point, but it was limited to express constraint. I was coming from the academic, field. It was very good, but people find that it was very complex. It required a lot of expertise. Recently, was Shackle came out 2017. That started this standard fill a gap. It didn't replace R, but it fell a big gap that was a validation and closed word assumption that Shackle brought. So I'm using both today, and then you had the emergence of AI, generative AI with large language model. And what happened there, where everyone was jumping on the bandwagon, say, "Well, this is great. We don't need AI. You know, we don't need ontology and semantic." They thought that they could solve all this problem with large language model. You know, in a regulated industry like insurance and banking, I mean, there's no room for hallucination. And one of the biggest challenge with LLM is like, okay, you give me this answer. If I ask you a second time, you give me a different one. I mean, okay, I cannot trust what you're saying, right? So they start to think, okay, I mean, how can you explain your reasoning? And there were no way really to explain that based on facts that were in the data. So people try to now see that where semantic and knowledge graph are bringing some value there, because the semantic technology is basically providing a framework to integrate all these data silos that are in SQL database or behind APIs or in document store or graph store. And you have a common framework to share the information and query them through Spark or query. I know you talk about a lot of, in the industry, we talk a lot about context graph. For me, context graph, I mean, that was obvious. 2000, when I joined Image Matters, I joined, they were talking about context sensitive application. So it's not something really new. We're just, you need a graph, and the graph is a context. It's just like you have your knowledge graph, and when the agent needs to ground his reasoning, we'll get the graph as a context. And they call it context, but it's just a graph. But there's also a graph that is semantic compared to graph that you find in label property graph, like Neo4j, for example, which are non-semantic. I mean, they have a layer that's kind of an afterthought, but most of the people use Neo4j for graph analytics. It's not really designed to integrate data silos across the board. You're really stuck to a vendor and a solution. But if you start getting, if you start to integrate like, 300 systems, like I've seen in some insurance company, Neo4j is just not going to work. You need to have a common representation, and that's why the ontology work start to be important. So I mean, now we are in a phase where LLM has really is kind of a yin and yang, the way I see it, right? LLM is providing an interface now is adding this interface that make the request of a knowledge graph and the building of ontology much easier. So it becomes more approachable and lower the bar of expertise. So that's why it's picking up. I mean, I was at the KGC, the Knowledge Graph conference last May, and it was the highest attendance in this year. So a lot of interest across all the industry. So it's really picking up. It took about 20 years to get there. but I never give up. I really believe in that. So yes, I spent my career working on this stuff.
Correct. So now, Stephane, also help me understand why is interoperability so important, right? Especially in today's context when things are moving so fast, you could use models to generate tons of code. Like what specifically makes interoperability so critical, right, for the long term for the enterprise?
Well, I mean, integration is probably the biggest application, right? I call it the killer app of knowledge graph. Integrate is
Okay.
solving an integration problem. What's happening is you have, a lot of work is done independently in that decentralized way, and everyone comes with their own schema, right? And that's the situation today. Everyone come with, I have a new JSON schema. Well, let's do interoperability with that, right? And you
Okay.
try to force everyone to adopt the standard. The problem is the standard is that, well, this standard doesn't fit my case, so I'm going to do another one, or I'm going to extend it. And the syntactic structure doesn't solve the problem, because what you're really trying to interpret is at the level of the meaning, right? And the semantic web is really providing this framework where everyone can talk the same language in terms of describing meanings, not in terms of describing the concept of a property. It provides the construct to do that in an interoperable way, and machine can do reasoning automatically with that, right? Using OWL and
Got it. Okay, cool. Okay, interesting. Now, going back to the yin yang concept that you spoke about, right?
Yes.
There is the neural part, which is the LLMs,
Yes.
and then there is the symbolic part, which is knowledge graphs and their versions, right? I want to understand, right, when you're building these systems, right, how do you balance, like, or how do you think about allocating work to these two systems,
This is a very good question.
especially in a production pipeline, right?
Yes.
Like the one you said. Let's say let's pick up insurance, for example, right? Insurance is a very sensitive, regulated industry. You can't make up stuff. You can't. You have to explain every reasoning.
Yes.
There are high stakes. So if you could just walk us through an example, right, of how these components are balanced, what roles do they play in these pipelines today, and how would it surface up at the end as an outcome? That would be very helpful for the audience.
Yeah, I want to tell you the way I do it, but also how not to do it, because I've seen both, right?
Yes.
Because I've seen a lot of. Let's start with something that doesn't work. So let's take an insurance. I'm not going to give any name. Let's say, I mean, most of these insurance, they grow through acquisition, right? And they acquire new system, and the system, they use their own application model, data model, and then they try to merge with the other one, and they try to make these things. Well, I know it's kind of like a software wasteland, like Dave Malcolm is calling it. It's like the word, everything is modeled around application, right? So to build an enterprise AI layer, you need to have an ontology that kind of define the business entities. What are the first-class business entities? And you start usually by the decision question you're asking. Let's say, for example, is this claim, how many claims this policyholder has done the last 5 years, right? This is an example. So you have, by looking at this decision question, you have this entity that emerge, right? And so you try to model the business model, right? The way you are running your business, you have to identify these things. So I've seen two ways, and both of them, I think, are wrong. The first way is like you pick an open ontology, like BFO, also, and each of these open ontology, they add to specific philosophy, right? So BFO, for example, philosophy of reality, right? They model reality and it's very philosophical. And you try to apply a philosophy to a business. And that's not really working, because when you commit to this ontology, you spend a lot of time talking about philosophical questions. Okay, what's a quality, or what's a endurance and perdurant? People are not really tracking when you bring these very abstract philosophical things, right?
Yeah.
So you are losing them very quickly there. Don't get me wrong. I mean, BF4 is used out there. There are some valid application like biomedical, They use it in DoD to some, their standard that are adopted at DoD. CCO, a common core ontology, is also one of them. Is an extension of BFO. So this is not usually the way I approach. I use that just like a guidance, like a thing about a map, and the BFO is a map legend, right? It's not really tied. It's a legend for understanding the thing, navigate, but you don't have to tie to that. The other approach that doesn't work, and probably the bigger problem is you start bottom up. You start from all the system you have, and you try to emerge the semantic. And the problem with that is like you are bringing a lot of semantic depth, technical depth, and assumption that are kind of born into these systems and very application oriented. And when you start building this ontology from that bottom up, you are bringing all this depth to the ontology, and they are not pure. So the way you want to start is not modeling for bottom up and not modeling from a philosophical approach, but start modeling your business, right? How you so operationally. So you identify this thing, and then usually I build this ontology in 2 layers because there are some common concepts that are cross domain, right? Like location, people, organization. These are these are across the board, right? So you have this layer that are a foundational layer, and you use different module and use existing standards as much as possible. So there's standard like W3C organization and sensor, the SOSA from a W3C for sensor observation. You have DCAT for describing data set. So it depends, usually I choose ontology that are small with few classes because they are easier to expand and reuse. So that's what I do. And then you have a layer where you have a common business, like the insurance layer, right? So the insurance layer will have like policies, claim, coverage, and these different concepts that are across the boards. And then the last layer is like the vertical property and
Property, correct. Property and
and
casualty, health insurance. Yeah.
right, DNO, and et cetera, et cetera. So, and then each of these layers build on top of each other, right?
Okay.
And so at the end, you get these layers that are well organized in modular, and you can just extend easily. So, so that's typically the way I do it. Modular, driven by the business decision, build the competency questions. Like question is very important because that's what gives a scope to your module, right? If you don't do that, you try to get it from the bottom up. You're not asking. You should start with a question. What you're trying to build? What question you need to answer? And the nice thing about competency question, it provides a way to do unit testing. Like you can associate as part of query and validate if your ontology is answering the question against some sample data. This is the way I build it. So, I mean, I can go more in detail, but that's the high level.
Okay, so you're saying that you will build an ontology in an incremental fashion, start small, and start with the business, modeling the business, and start with a few specific, start with a very small scope, and then expand. Expansion is much more easier than trimming down a much bigger ontology and reducing the scope of it. Am I hearing that right?
Yeah, but one thing I haven't said is like, don't try to do everything at the same time. Pick a domain like a claim or policy modeling and just get it end to end and test end to end. Like build your API, build your agent, and get early success. Because once you show the early success, then you can go to the next part of the thing. You want to prove success as soon as possible, because ontologies, they have this, people say, oh, the ontologies get in a room, it takes like 5 years to come to a decision whether something is a data type or an object property. No, you want to get quick success and do it and start with one that with the pain point of a company that the most pressing to solve, and show success with it, and then move on.
Got it. Okay. Now, Stephane, because you also work as a consultant and you consult large enterprises in these very difficult to navigate industries and customers, and how are you approaching this work of building semantic infra before LLMs, right?
I was tedious.
How, no, I agree. What has changed specifically now versus then? I
What
think
has
that's
changed?
that's the
A lot
first
has
question. Yeah.
changed. I mean,
Uh-huh.
look at, for example, I mean, coding. I mean, I don't code anymore. I mean, I code, but I don't look at the
Yeah.
code anymore. Almost nothing,
Yeah.
right?
Yeah.
It's just done with prompts and using the right tool. Where with ontology, I mean, the AI, I mean, is I don't make I don't let AI building the ontology for me, but I have these guardrails. Like I explain, okay, what I try to do, and then I say generate the competency questions, right? LLM is great at that, right? And then you can give you suggestion. The LLM can help you to find the right term or the right hierarchy, but you always have to be in the loop
Mhm.
because so it speed up 80% of the tedious work from ontologies. No, is
Mhm.
automated, right? If you get the right guardrails and you know how to use a tool and you know the standards, you know that competency question needs to be backed by some Spark or query, and you need to encode the term in all or RDF schema, and the validation you need to do a shackle, and for reference data, use COS.
Mhm.
Writing the scores, writing the R. I mean, I used to use Protege or TopRed tool to do this ontology. I don't need that anymore. I just use, I generate the code to validate and do the reasoning, and
Good.
AI generate the TTL, and it validate by itself also because it can write the code to do. So 80% of the time I used to spend is done with AI, and 20% I'm really focusing on the modeling, the ontology, and the proper pattern, and the right modularization. And the AI cannot do that very well. That's where the human judgment play a very important role.
Very important role. Get it.
Yeah, yeah.
Okay. Now, how does that? So that's what has changed on your personal end, and you're working with some of these tools to build such solutions. What has changed from the expectation of the large enterprise or the CFO who is eventually engaging with consultants and companies like you? Do they expect this to happen now automatically and not invest in the semantic web? If not, how do you explain? Because see, in a world of hype, where everybody can build a knowledge graph and in with one prompt, right?
Yeah, all of a sudden, everyone is an ontologist.
Everybody is. Everybody has a point of view on building knowledge graphs, building knowledge lab, and so on. So
Yeah.
how do you sort of now explain the time and effort that validation is critical? Exactly what you said, that LLMs can do so much, but like you still need a human to validate, curate, establish meaning, ensure that everything has the right interpretation, and so on and so forth, right? Because this, what you're saying is, they had this magic wand and they expected, okay, we can just wave the magic wand and get a semantic layer. But you're saying no, that's not how it works. How do people handle that, and how do you sort of explain that to a CFO at least, right? Who's sitting with like a real budget and say, no, this will take some more time. Yeah.
Yeah, I have some client where they started the
Hmm.
project and they decided that they're going to build enterprise ontology using purely LLM, and they're going to generate all the ontology bottom up, as I say, and they say, oh, give a schema of a database, it's going to figure it out, it's going to build ontology, it's going to find out automatically the thing. And you look at, I'm coming in, I look at the result and I say, this is not an ontology. This is just tables with RDF dress. Right? This guy's in RDF, but it's just table and column. So they have not moved a needle. For example, you have a table, like they have all kind of identifier, right? For code of all kind of classification, like industry classification or social security number, whatever. They have a column for each one, but if you really think through, they're all identifier, right? And you can create one class identifier where you say these are
And have a
value
subclass.
from this scheme, right? But no, they
Yeah.
define 50, 100 properties, which is exactly 101 with a table, because they have been designed by data. This ontology have been done with large language model, designed by database modeler who don't know about ontology and don't understand what an ontology is. And you end up with a model that looks like a relational model on steroid, but that doesn't achieve any interoperability. You end up with I mean, I've seen some ontology that have like 1,000 classes and properties total, which is insane. I mean, it's just like, how are you going to give this ontology to interoperate with 15,000 terms to understand? I mean, human cannot even have, you know, more than 300-400 concepts in a business, you know, so 15,000 is going to work. I mean, no one is going to use that. So
Yeah.
so that's why I say start with a decision question. You know, what are question your business needs to answer, and then start with modeling the business. Don't think about the implementation, how we're going to be implemented. Just think about how conceptually you understand your business. Describe entities and also describe the process, the data in motion, how we are moving through the process, right? This is very important because you have like the data at rest and you have the data in motion. You need to model both because the data at rest are modified by this process. Some event happen and they act on some entity and they go through a pipeline and you want to have everything be explainable. So this is very important. I mean, a lot of people are missing this you know, these two.
Got it. Okay. So that it makes sense, right? What I do want to understand is this, in this specific case, the client had some understanding that they need an ontology.
Yes.
That they should invest in, you know, such structures, such systems, and they would use some tools, right? If not a real ontologist, which is okay, right? You learn the lesson hard and fast. What happens when you are working with customers or clients who come in, right, who might not have worked on or who might not have deep understanding of, you know, semantic systems, ontologies, and so on, right? What's your way of explaining to them that because now we do see a lot of people who have hit a glass ceiling with their, you know, vector RAG, right? And like, you know, we can't break through this, and they have put in a human in the loop to, you know, essentially solve for the remaining 20%, which actually is very difficult because the more complex the system, the more complex the work, and the more it takes to verify the output of the vector RAG. Half the time there is fabrication, half the time it messes on, you know, like very important stuff, and then it starts creating, you know, expectation gaps, right? And then everybody starts to blame the model and so on. But then, so when such clients with such systems are already in place come into you, right? How do you sort of walk them through? Because what you're saying is you need to step back and start modeling your business first, right?
First of all, you try to explain you have to relate to the pain they have, right? And the pain they have is always the same. I go any industry, it's all the same. They cannot interoperate and they have data silos that is all application centric and they freaking need to exchange the data and be able to connect them. Everyone will acknowledge they have this problem. The problem is how they proceed to it. The second phase is to explain that, you know, structure and syntax is not solving, is not the problem. You have to go to the root of the problem and articulate that very well. Why we have this problem today? What is the problem? I mean, what is the root cause of that? It's because everything is syntactic, because everything is structural, and the machine, if you give a table with a column name, it has no clue what it means. It doesn't know. For example, you have a column XY, right? It's a lat long. Okay, well, there's a lot of information missing there to make it usable, right? What is a projection? What is a unit of measure? What is a value? Is it a degree decimal or degree a minute second? All this thing is implicit in the data, right? And what you need to do is extract this semantic, make it explicit. So, and the other thing, you want to comfort them that by saying, okay, you don't need to migrate all your data from one system to the other. What we need to do is lay on top of your existing system, keep what you have, but we need to have an adapter to emerge the semantic that's missing, right? So you have an API, for example, that returns some JSON. You lift the JSON by making all the implicit explicit and turn it to a knowledge graph representation. So actually it's not so hard to implement, but a lot of people don't understand the architecture. This implicit data information that are not expressed. That is the main problem of interoperability. Is a lot of assumptions that are made and say, you have to read the doc today to understand. You give a schema to someone, they have to go to the spec and read the spec, what this column means, and read a human, some description. But most of the time, they don't have this information. The database, they have to guess, and problem happen after that. I mean, crash happen on Mars, and they have this issue with kilometer versus mile. They were working international team, and a proper crash on Mars planet because interoperability problem. So it sometimes can be very costly.
Got it. Okay, perfect. Now, I want to go back to the latest claim or latest trend, which is, to your point, you start with modeling your business. You start with your policies, procedures, documents. You create that business. You create that model. Maybe you can also use a domain ontology as well if you want to, or parts of it, and so on. But then people are also now advocating for this third layer, which is coming in from your Microsoft Teams or your Slack or your emails, which is where also a lot of decision traces exist potentially, right? And they could also be layered in or baked into your ontology with some level of curation, maybe. Right? What's your read on that? Like how because you've actually built some of these systems, productionized it. Is that really a thing? Like, does that make a difference? What's your read on that?
Like integration with services like Slack, ServiceNow, email.
Yeah, I mean, more than the integration, would that be valuable from an outcome perspective, right? Would the agent that is, let's say, processing claims or deciding whether this claim is good or bad, right? Would those agents do better if they have this sort of information also accessible in the right structure, of course? What's your
Right.
take on that?
Yeah, I mean, of course. I mean, the agent needs to be grounded into facts, right? So if it needs to access the data, the enterprise data, and there are many mechanisms to access them through API, to query on a database. But what you want is having one framework to represent all this data. There is no need to have multiple API. So that's why you want this semantic layer to unify. So the agent see one graph, a semantic graph, instead of seeing thousands of API and system and tables. So the work is really at the bridge, the adapter that you are bridging the data source to your semantic representation. After the agent will have one way to do to get access to the context, to get context graph. You have MCP, for example, they use the term context, so probably that's where the term comes from. But still the MCP doesn't return RDF or model, it returns JSON. So it's still not interoperable. You still have to deal with structure and syntax. So it's really important you make it like a semantic grounded where the meaning is expressed explicitly so the machine can do reasoning. Otherwise, it's a end-to-end problem here.
Yeah, yeah. Yeah, okay, interesting. Thanks. That's very helpful, right? But they do not understand the world of semantic web. They don't understand ontologies. They don't understand taxonomies. They don't understand knowledge graphs in depth, right? Where would you recommend them to start if they have to explore this path, right? How should, and what sort of milestones would you set for them if they were to, go down this path of building upon this framework? Yeah.
Well, first thing is they have to understand that any data can be represented as a graph, number one. Okay, a table, JSON tree, XML tree, everything can be represented as a graph, right? Now the question is, let's take this assumption, this semantic layer. If you want to unify, it will have to look like a graph, right? Everything connects. So that's number one. Number two is understanding, okay, what are the different graph technology out there? There are two main categories: semantic graph, knowledge graph, and the label property graph. The property graph is like the word of Neo4j. I'm not trying to say anything bad to VVS. It's place for graph analytics, in my opinion, do a great job. But the question is how you're going to use it and do reasoning. So that's why if they to understand the difference between LPG, label property graph, and RDF, they will understand what meaning means. So that's the second thing. And then start looking at semantic web standard, right? For if they are not, if they are the web developer, I will start with JSON LD, right? Because they know JSON. So JSON LD is, they only have to understand the notion of a context. And that's where they're going to have a bridge to this URI, right? The field maps to the URI. And they're going to see like, oh, they have this list and they have this language and this data type. They're going to discover RDF this way, right? But then they have to understand the RDF model, right? So what is this property and data type, literal and class, right? That's where they have to start learning, okay, this is RDF. This is a simple model representing a building block for a graph. This is a standard. There are many serialization. There are TTL, there are JSON LD, there is RDF. Then there's the next layer is how do you define the schema for a graph? Start looking at RDF schema, right? There's a notion of domain, properties, subclass. Okay. Now you want to be a little more expressive. You look at ontology web language, right? This is where you have this axiom, a transitive, functional, different intersection of classes, union of classes. And the last one, not the last one, but the next thing is how do you validate the data that come into your graph, right? Then this is where Shackle comes in. They have to look at Shackle. And there's another part is how do you represent your glossary, your code list, your tezeri, and these are the value that are on your entities, on your classes. How do you organize that? How do you do the governance? How do you map this taxonomy or control vocabulary between each other? Because sometimes you have two taxonomy, but they are not exactly the same. So you need to do correspondence between them. There they have to look at SCOS, SKOS, right? This is a standard used for representing scores. And then start looking at, systems that use these standards, schema.org, DBpedia, Wikidata, to understand how, if you go to Wikipedia, you will find a web page. If you change Wikipedia by dbpedia.com/resource and put the same name, you will find the RDF representation of the page. And they can navigate through the semantic web there. So they will see how things are linking together because this is open data, open link data. They will see how it works in the public, right? In open world. They can apply the same mechanism in the enterprise. And of course, then Sparkle is the query language for the SQL equivalent for Sparkle RDF. And and just look at, article read that is used in the industry and play with some API and try to model a small part of the enterprise and see how it works. So, and also try some graph database, there's some open source like RDF4J, Jena. They can look at commercial company like Stardog or GraphWise, Ontotext. So so that's what the path I will advise to follow. But the first thing is understand the graph. Why a graph, right? Once you start with this question, then you build up. Every step should be logical. I mean, one will lead to the other naturally. If you try, does that answer my problem? And you will see that it will. So that's my advice.
Perfect. Thanks. I have one last question from my side, which is, and we ask this from every guest that we have on the show, which is, if there was one thing that you could change about how enterprises are approaching agents and AI applications today, and it actually happens tomorrow, what would that be?
If I have to change something, try to.
If yes, about how enterprises are approaching agents today, and they actually are able to fix it tomorrow, what would that be?
For me, agentic AI will only succeed if they can describe themselves semantically and you build a layer of trust on this web of agents, right? What I mean by that is like any agent that wants to interact with another one, they have to be able to present credential and to be authorized for performing some activity within, a company. So that's kind of the idea actually behind the spatial web. That's why I love this. I'm very passionate about this one. They start from the ground up, like, okay, The spatial web is like um, the foundation from scratch is built on the layer of trust. So they use this standard like DID and verifiable credential that the agent communicate. And HSML, the standard I've been building for the spatial web foundation, is describing what you call this domain. Domain is basically a holonic entity that contain like agent performing activity on thing, and they have to perform this activity according a contract. So when the agent comes in that try to enter with this domain, they have to present credential and they have to satisfy the policy of a contract to perform the action. If you build this foundation, which is missing today, like you want to send an agent, wants to do you want him shopping, and he has your credit card. You have to tell him what he can do and not do, right? Where website can go, how much he can spend, and this kind of thing. So it is very important that we have this layer build
That
up
exists.
foundation,
Yeah.
because the trust in the web today, it's an afterthought. The web, when they started, never thought about security. It was layer added on top. And that's why you have so many cybersecurity problems today, because it was never designed for this. So I think we have to refigure that from scratch. That's what the IEEE standard for the spatial web is trying to address. I think it's a great vision. It will take a couple of years to get there, but that's my dream. A world where your agent can interact with digital twin, like, because I do a lot of geospatial, performing activity in the virtual world, and, everything is automated. Like you send a drone in a city, and he has to follow some regulation. You have a contract within the drone, which is an agent, and he will have to present that to, be issued by the FAA. Say you can fly from there to there, and they're authorized to do it. So this has to be built in. It will take years to do, but this is a way I see the convergence of blockchain and agentic AI and semantic all together. It's kind of building the HTTP and HTTP and HTML stack that they have designed this HSTP hyperspace protocol, transport protocol, and HSML hyperspace modeling language. So that's kind of the idea. And HSML is all described semantically, can describe agent and things and activity all semantically. So that's kind of the idea.
Awesome. Thank you so much for this, Stephane. I really appreciate you going into this detail and your experience and passion of this subject clearly reflects. I'm really glad that you're finally able to record this episode. Thank you so much for taking the time for doing this.
Yeah, thank you so much for inviting me. I appreciate it.